Welcome to The Explainer. We spend so much time looking at the bright, shiny stars. But what if the real action is in the darkness between them? Today, we're going on a hunt for a whole population of hidden worlds. All right, let's just jump right in with a question that, well, it pretty much flips our entire picture of the cosmos on its head. I mean, you think planet, you think star, right? They go together. But what if that's actually the exception and not the rule? Because get this. There's a ton of evidence piling up that suggests our galaxy is just absolutely teeming with what they call nomad worlds. We're talking about planets just drifting free, completely untethered, in the dark. And here's the kicker. There might be more of them than all the planets orbiting all the stars combined. Just let that sink in for a second. Okay, so let's get to know this invisible population. Who are these dark wanderers? And how did they end up all alone out there? Well, a rogue planet is pretty much exactly what it sounds like. It's a world without a home star. They get their start in the crazy, chaotic early days of solar systems, and then, a bit of gravitational roughhousing, and bam, they get flung out into the void. These cosmic orphans can be huge gas giants or even tiny rocky worlds just like Earth, all destined to just wander the galaxy forever. Okay, but that brings up a pretty massive question, right? If these things are pitch black, floating in the dark, and they're just unimaginably far away, how in the world do we even know they're there? The answer is, honestly, one of the coolest tricks in all of astronomy. It's a wild phenomenon that Einstein himself predicted, called gravitational microlensing. Basically, you can't see the planet, but you can see its gravity. And for now, it's literally the only way we have to find the really small, Earth-sized ones. So here's the rundown on how it works. Imagine a rogue planet happens to drift perfectly between us here on Earth and some really distant star. Its gravity literally acts like a cosmic magnifying glass. It warps space-time itself, and that warp bends the light from the star behind it. For us, it looks like the star just briefly and very predictably gets brighter. We're not seeing the planet at all. We're seeing the telltale signature of its gravity passing by. So cool. And hey, this is not just some neat theory. This is real. Back in 2020, astronomers used this exact technique and found the very first candidate for a rogue planet that's about the mass of Earth. A tiny, brief twinkle from a faraway star gave away the location of a small, dark world just wandering through the galaxy. Okay, so we can find them. That's awesome. But without a sun, they've got to be just frozen dead rocks, right? Case closed? Well, maybe not. This is where the story gets really interesting. We've got to look inside. Scientists have come up with a totally awesome name for these potential life-harboring rogue worlds. They call them Steppenwolf planets. I love that. It brings up this image of a lone wolf just wandering the massive, cold steppes of the galaxy. And the whole idea is that these planets, even out in the freezing cold of deep space, could be warm enough on the inside to have liquid water. So how on earth do they stay warm in that freezing void? Well, it turns out they can have one of two kinds of internal engines. First up, you've got something called radiogenic heating. You can think of it like a giant planet-sized nuclear battery. You see, when the planet formed, all these heavy elements like uranium and thorium got baked into its core. And as they slowly decay over billions of years, they release a steady stream of heat. Then there's the second option, tidal heating. This is really cool. If a rogue planet got kicked out of its solar system but managed to hang on to its moons, the constant gravitational tug-of-war between the planet and its moons would create a ton of friction. And friction means heat. It's the same exact process that keeps the ocean liquid under the ice on Jupiter's moon Europa. And this right here gives us a perfect cross-section of what that kind of world could look like. On the outside, a super thick crust of ice. It's the perfect insulator, protecting everything below from the absolute zero of space. But underneath that ice, a massive global ocean of liquid water, kept warm for maybe billions of years by all that geothermal heat coming from the active core. Just stop and think about that for a second. An environment that's totally stable for billions of years. There are no solar flares to worry about, no catastrophic asteroid impacts, no solar winds stripping away an atmosphere. Tucked away under miles of ice, these hidden oceans might just be some of the most stable, most protected habitats in the entire galaxy. And that stability, that protection, it leads us to the biggest question of all. Could life actually start in these dark, hidden oceans? To really talk about this, we actually need a new word. We all know the word habitability, right? That's an environment that can sustain life that's already there. But scientists are starting to use a new term, mutability. And that's all about the potential for an environment to originate life, to get it started from scratch. It's the difference between a nice home and the actual cradle of life. And this is where things get really, really exciting. I mean, you've got a stable supply of liquid water, plus a constant source of chemical energy from hydrothermal vents on the ocean floor. These dark oceans could be the perfect little labs for all that prebiotic chemistry to take place. They might just be some of the most habitable places anywhere in the cosmos. Okay, so if you take this idea all the way to its logical conclusion, you get to a possibility that is, well, it's just mind-bending. Some scientists are proposing that if life can start on these worlds, and if there are literally trillions of them wandering the galaxy, then they could basically act as interstellar seeds. They could carry life from one star system to another. The whole concept is called panspermia. And that's what we're left with, this really provocative final thought, that maybe the huge, empty-seeming darkness between the stars isn't so empty after all. Maybe it's filled with countless dark worlds, silently carrying the seeds of life across the entire galaxy, just waiting for us to find them.